Tonight's event is co-sponsored by People's Bank because they believe in dialogue and curiosity in the community. With that, I'd like to introduce my guest tonight, Dr. R. Thomas Zoeller. He is a professor of biology at the University of Massachusetts Amherst. His early training was in molecular neuroendocrinology at the National Institute of Health in Bethesda, Maryland. His current research focuses on the role of the thyroid hormone in brain development with an emphasis on fetal brains. Dr. Zoeller's lab also studies the mechanisms by which environmental endocrine disruptors can interfere with thyroid hormone action in the brain, and his laboratory has published over 100 peer-reviewed papers on this topic. That's a lot. He was a member of the U.S. EPA's Endocrine Disruptor Screening and Testing Advisory Council Committee Working Group on Screening and Testing in the 1990s. He's currently a chartered member of the EPA's Science Advisory Board and is the chair of their Exposure and Human Health Committee. He's received numerous awards for his work, including the Scientist of the Year in 2002, from the Learning Disabilities Association, a Samuel F. Conti Award for Research Excellence, and recently received the UMass Chancellor's Medal. He's written extensively on issues of endocrine disruption and public policy and was one of the editors of the recent State of Science of Endocrine Disruption published by the Joint United Nations World Health Organization project. That's huge. He welcomes questions during his talk, but we will also focus on questions at the end. We'll have 2 microphones up near the stairs so you can ask questions at that time. But with that, I'd like to welcome Dr. Zoeller to the stage. Thank you.
Well, it's really a pleasure to be here. I gave a talk here during the day. I think it was a noon seminar a couple weeks ago. And I'd really never been here that much. I haven't even been in Springfield that much, although my son went to high school in Springfield. So I used to go there and talk to the dean of students a lot. I'm sure he'd love that. So what I'm going to do is start out by talking about this issue of chemicals. We read about it, and you read very different things in the New York Times. In fact, there's a columnist at the New York Times that'll often write some column that really makes a lot of sense, and then you'll hear something else on the radio that will be just the reverse, and it's very confusing. So there's, in fact, when I was looking around, when I was thinking about this issue of how confusing it is, I saw a couple of these kind of advertisements. Keep kids safe with flame retardant Halloween. This just came out. I mean, this is new, like now. It's interesting because the Chicago Tribune did a 4-piece kind of investigative report about a year ago that, first of all, demonstrates that flame retardants really aren't saving lives or property. So it's kind of a myth that they keep us safe. On the other hand, my lab has studied the way flame retardants can affect thyroid hormone action in the fetal brain. I think it's much better not to use these kind of things. Also, what's actually scary? Environmentalists with time on their hands. And then on the other hand, you see all these kind of images here. It really is very confusing. And so I kind of want to start with this issue, and I'm gonna dissemble at least one issue. This is a writer that wrote this kind of a blog about cancer prevention tips to avoid. Now, this person works for the Independent Women's Forum and the Competitive Enterprise Institute. She has a PhD in politics. So what she says is that none of the tips, and basically these are tips about how to avoid plastics, don't microwave your plastic, or this, that, and the other. And she says that none of these tips actually help anybody, because if chemicals in the environment, I've got a cold, so I'm struggling, and I gave a lecture today in my class, so I'm struggling a little bit. If trace chemicals were a significant cause of cancer, then cancer rates would be going up instead of going down like they are. And so she's saying in its annual report to the nation on the status of cancer, the National Cancer Institute reports that since 1975, cancer incidence has continued to decline among men and for women. Now so what does that mean? What is she really saying? So I went to the annual report to the nation that she referred to. What it says is that incident rates among women increased from 2000 to 2009 for 7 cancers. You can see them listed here. In fact, thyroid cancer is actually the fastest growing hard tumor at a rate of something like 3% per 100,000 per year. So it's increasing at a high rate, and it's also mainly women. Incidence rates were stable for all other cancers, including female breast cancer. So let's think about that for a second. What's true here? Then it goes on to say that although overall breast cancer incidence rates stabilized, it's still the highest incidence of all the cancers in women. I'm not sure that's where we want it to be stable. And then generally, breast cancer had the highest incidence rate. That's what that was saying. Then there was a paper that came out in the Journal of the American Medical Association in March. And what they were studying is metastatic breast cancer. And they wanted to look at the incidence of metastatic breast cancer. And what they find is that the metastatic cancer incidence rates began decreasing in 2000, not in the 1970s, after 20 years of increases at fairly high rates. One theory relative to this decrease has to do with the way standard of care has changed for postmenopausal women and the combination of progesterone and estrogen therapy after menopause. And so once the Women's Health Initiative that was funded by the NIH began to see some problems, they changed the standard of care, and as a result, there was a decrease in breast cancer in older women, in women over 50. So their conclusion from this study was based on, this is a registry database that the National Cancer Institute maintains. There was a significant increase in breast cancer, in this metastatic breast cancer, in the US between 76 and 2009 for younger women, but not for older women. So breast cancer, as well as other cancers, are very heterogeneous. The incidence rates really depends on this kind of stratification of the age of the woman, in fact, whether women had had children, when those children were born, whether they breastfed. There are many factors that go into breast cancer incidence rates as well as others. So the typical response to this is that, this is too complicated, and you can sort of give up and just say, this whole thing is crazy, I'm just going to forget about it. I think one of the reasons that it seems so complicated is it actually is complicated. The human body is very complicated. Physiology is complicated. Medicine and disease is complicated. We don't know how cancer starts, and we don't know how to fix it. If we did, we wouldn't really be having most of these discussions. But there's an awful lot of unknowns when it comes to these kind of issues, and they're important issues. And there are issues that you would think that everybody would be on the same side of the table. It's the side of truth and public health and sort of, humanity. But that's not always the case, I think. So there's 2 issues that I want to talk about. I left this in here, and I'm not going to talk about black licorice. It's a really interesting story, but I'm not going to talk about that. But let's talk about smoking for a minute. We've all kind of been through this. Today it's a little bit different. Smoking is a problem, but when I was growing up, these are the kind of ads that you got, that you saw all the time. You know, movie stars are saying that this cigarette is the best, and then they had, you know, a dentist is saying he's recommending Viceroys because they're filtered. Here's I love this one. 20,000 physicians say that Luckies are less irritating. I mean, do you really think 20,000 physicians said that? I can't imagine that. And of course, everybody's so happy and go lucky. This was the 1950s and 1960s. If you, I did the same thing that, if you Google cigarette smoking today, you see a very different picture. And in fact, I'm being very kind of polite by putting these pictures up instead of some of the absolutely horrific kind of images that are on the web today that have to do with cigarette smoking and various cancers. So it's clear you don't get a good image of cigarette smoking if you Google it today. So what happened between, you know, many of us lived through that period of, you know, watching What's My Line, and they're all smoking and talking about the cigarettes that they were smoking, and today, you know, that's not even on TV, this kind of stuff. So what happened? So I think the first thing was that the evidence linking smoking to cancer became absolutely overwhelming. It was no longer a debate, and in fact, a lot of people who talk about this issue today will say that the data were convincing long before this cultural shift occurred. Also, lawsuits that were brought by individuals initially revealed in their discovery process, revealed how much the tobacco industry misled us and really lied to us. They didn't just lie to us, they lied to Congress. In fact, I arrived at UMass in 1994, and about a month later, I remember hearing on NPR the CEOs of the 7 major tobacco cigarette manufacturers in the US were testifying in front of Congress. And they each made the statement that nicotine is not addictive. So each one of these 7 people made the statement, and I'm just thinking, you know, this is 1994. This was not an issue. And of course, in these discovery processes, it turned out that they were doing studies on addiction. So they knew how much nicotine to put in the cigarette so that people would be addicted. And when they started advertising, you know, low tar and nicotine, they made sure that that nicotine didn't drop below a concentration that would not be addictive. They were absolutely clear about that issue. And yet, each one of them stood in front of Congress, they were sitting, and said, nicotine is not addicting. So a big part of the reason that it took so long is that there is a very well-funded campaign to maintain the status quo. And there's uncertainty. So one thing that I kind of want to talk about here is this uncertainty. The initial lawsuits that were brought against tobacco companies on behalf of individuals who had died or were dying of lung cancer all failed, because we all know that you can get lung cancer if you don't smoke, and if you do smoke, you don't always get lung cancer. In fact, 11% of smokers get lung cancer. So it's not, if you look at an individual basis, it's uncertain. If you look at the population, it's clear. And that's why when the attorneys general filed suit, a variety of states, in fact, I think Massachusetts attorney general was the first, Scott Harshbarger, I think, was attorney general there and at that time, and they won. You know, they won this lawsuit, and they won it because on a population basis, you can state unequivocally that smoking causes cancer. But in an individual, you can't do that. And the reason I'm using this as an example is this is exactly the problems that we're having with endocrine disruptors. If somebody has a problem, an individual problem, a clinical syndrome, you can't point to what the issue was. But on a population level, you can say that people that are exposed to these chemicals have a higher risk for these kinds of problems. It's very clear. The other issue is that we know who's smoking. People volunteer to do it. You don't volunteer to take bisphenol A or take pesticides or take any of the other number of chemicals that we're exposed to. So we don't know. Nobody here can say what your number is for any particular chemical, PCBs or flame retardants, etc. We've all got them, but we don't know what they are. So the relationship between exposure and impact is much more difficult in this issue of environmental chemicals. And so the degree of uncertainty is greater. And the ad campaign, this campaign against changing the status quo, is every bit as big, if not bigger, than what it was for smoking. So what I want to do is kind of talk about endocrine disruptors. What are they and how do they work? What are the human studies that make people think that there's a problem here? What are the mechanistic studies? Because if you can't, we can't go in and test people experimentally. So you have to do this in kind of mechanistic studies, and those mechanistic studies include things that are just in the test tube, biochemical studies, but also in animal studies. How do regulators look at this science? And this is a really important issue. And then how does industry look at the science? And I'll give you some examples toward the end. So first of all, what's an endocrine disruptor? It's been defined by a number of entities. Here's the World Health Organization, the European Union, and the US EPA have all kind of come up with a definition. But the definition is really for the purpose of regulation and litigation. And it becomes really complicated. I had an early version of this talk where I had the whole kind of rigmarole up there, and it's not really worth looking at because it's very complicated and very confusing. The Endocrine Society, which is the largest clinical society of endocrinologists in the world, came out with the definition that says that an endocrine disrupting chemical is an exogenous, meaning it's some chemical outside the body, or a mixture of chemicals that can interfere with any aspect of hormone action. And the Endocrine Society got a little bit of pushback on that at the very beginning because they didn't say, and produce adverse effects. But the reason they didn't do that was that, what's an adverse effect? So if you're a regulator, an adverse effect is death. That's something. It's something that's tangible, you can measure it. It's also changes in body weight or organ weight, acute measures of toxicity. And hormones don't necessarily do that, and endocrine disruption doesn't necessarily do that. In fact, we know good studies showing links between hormone disruptors in development and adult onset of cancer. So that's going to be a really hard thing to link because you've got 20 or 30 years intervening between exposure and outcome. So the Endocrine Society didn't put that in there because I don't know of an endocrinologist who could say with confidence that if you interfere with hormone action during brain development, let's say, in my case, if you interfere with thyroid hormone action in fetal brain development, is it possible that that couldn't be adverse? And I can't imagine how that's possible. So what is the endocrine system? It's really depends on how you define it, like most things, I guess. In the old days when I was an undergrad, we would define it as a series of glands that produce hormones, and these hormones are molecules and they go out into the blood and they do stuff. So that's kind of the endocrine system, but they do big stuff. They control body weight, they control metabolism, during development, they control important things like development of the brain. So how do they work? These are small molecules that travel through the blood, and in this case, this is an example of a steroid hormone that can leave the bloodstream and actually go through this cell membrane. And in this case, steroids like estrogen and androgens and thyroid hormones, even though they're not steroids, can travel into the nucleus of the cell and regulate gene expression. Okay, so early in development, this is one of the things that my lab does, is to look at what the genes are in the fetal brain that are being regulated by thyroid hormone. And of course, the fetus can't make thyroid hormone until 20 weeks gestation. 20 weeks is pretty late. So you've already got a brain, you've already got all this development that has occurred, all because maternal thyroid hormone crosses the placenta and regulates gene expression in the fetus. Okay? A cell that is a liver cell is different from a brain cell because of the genes that it expresses. They're different. And thyroid hormone, in part, plays a role in that. The way your brain is organized, in part, is due to the way thyroid hormone acts on this kind of process. Now, for this hormone to be able to regulate gene expression and do anything, it has to bind to a receptor. It's a protein. In this case, it's a protein in the nucleus that it will actually physically sit down on the DNA and tell that DNA to do something different. So one way we can think about these receptors is it's kind of like a lock and a key, where this is a kind of a picture of a nuclear receptor sitting on DNA. This is the DNA strand here, and estrogen might come along and bind to this protein and cause that protein to move, much like this key will fit into the lock, and it could, as soon as the key fits in, it can turn and open that lock. So it opens up a whole bunch of different things. That's what estrogen is doing. It binds to this protein, which causes that protein to, I keep hitting a button here, that it causes that protein to change its shape. And when it changes its shape, it institutes some changes in the DNA. So these chemicals, and we've shown a number of chemicals that can bind to the thyroid hormone receptor, and it'll fit into the to the lock mechanism, and it either turns it on or turns it off, or it does something totally different. And as a hormone guy, I'm really interested in the way you can actually make a nuclear receptor do something that it's never done before, just by the shape of the molecule that you fit in there. Because if the molecule isn't a perfect fit, it contorts that receptor and causes it to regulate different genes. So endocrine disrupting chemicals don't just act like a hormone or block a hormone. They can actually cause the hormone system to do something different. It's kind of like a virus in your computer. All of a sudden, your computer starts doing something that you didn't tell it to do. And that's what is so, I think, kind of scary to me about endocrine disruptors. So if you think about hormones early in development, this is long before the fetal thyroid gland will work. The mother's thyroid hormone has to come in and drive the development of this brain. And in order to have normal brain function, the mother needs to have a healthy thyroid, and the baby, when it's born and also immediately after, needs to have normal thyroid function. And in fact, every baby born is measured for thyroid hormone because it's so important. It used to be said that about 1 in 4,000 babies have what's called congenital hypothyroidism, and I'll talk about that a little bit later. But today, the incidence is about 1 in 1,200. It kind of depends on where you live, and it's not really clear what's going on. But there's a lot of concern that congenital hypothyroidism, which seems to be idiopathic, so we don't really know why it's happening. But the thyroid gland in the baby doesn't form. And as a result, or it forms improperly, and as a result, it doesn't make thyroid hormone, and the baby is at a huge risk. A baby that is not identified by this screening program will be severely mentally retarded without therapy and without therapy that initiates within 1 or 2 weeks. So it's a critical issue. So an issue that's so well understood like that and is so clear that the money it takes to run a national program of surveillance and treatment would not even be represented in any of the tests that industry does for endocrine disruptors. So I'll kind of end on that note, but I'll give you kind of a heads up that that's where I'm going. And that's really one of the reasons that I have been so kind of outspoken to the EPA, to industry, to Congress, but boy. So what are human studies about endocrine disruptors telling us? Well, the first thing it tells us is that we're exposed. That's one thing that we need to recognize right away. So this is the CDC, the Center for Disease Control and Prevention, runs a biomonitoring program. And so what they do is measure, they take blood and take urine, they measure all these chemicals, and they measure a whole bunch of them. And to give you kind of an idea, the recent update has all these chemicals here listed. And if you can't read it, I'm surprised because it's all really clear to me. So this is just the update. The original, this is page 1 of 7 pages of chemicals that they're measuring in the human population. Remember that this is in about 16,000 people nationwide, and it's a statistical representation of the human population in the US, including the diversity of people in the US. So it's a very big program. And what is this program telling us? First of all, it's telling us that we're all contaminated with a whole bunch of different chemicals. In part, it depends on where you live, but there are certain things that we all have. Polychlorinated biphenyls are one, polybrominated diphenyl ethers, these are flame retardants. PCBs were banned in the 70s. Despite the fact that their production was banned in the 70s, we've still all got them. So one of the other lessons here is that you don't make a decision to regulate something and have an instantaneous effect. For a lot of these chemicals that are long-lived, it's a problem. I also have to say that PCBs were banned by Congress, not by a regulatory apparatus. And I've made the argument to EPA multiple times that if PCBs went through the regulatory apparatus today, they would be given a green light just like they were in the 50s and 60s, because the system hasn't changed. And when they argue back to me that, no, that would never happen, I keep saying, wait a minute, you can't tell me that all your tests are the same as they were in the 30s and 40s because you've got a lot of experience with them, and then tell me that they're doing a lot better job now. It's not, those two things are incompatible. It's just not logical. But the biomonitoring study only looks at kids that are 6 years old and older. What about infants and newborns? So the government doesn't do this. There was a study that was published now a while ago in 2005 that was done by the Environmental Working Group. And what they did, really all they did is kind of manage the collection of 10 cord blood samples from the American Red Cross that were randomly chosen and had those cord blood samples sent to an analytical lab where the Environmental Working Group paid the lab to measure about 400 and some odd chemicals. So how many chemicals did they find in those 10 cord bloods? Almost 300, 287 different industrial chemicals in 10 samples of cord blood. There wasn't a single sample that had fewer than 115 different environmental industrial chemicals. So I'll talk about this a little bit later. So we're exposed. So then if you look on the disease side, before we try to put this together, our exposure and diseases, what kind of things are happening? So what we see is, first of all, an increase in a number of pediatric disorders, including a variety of cancers. That turns out that, that astrogliomas, brain cancers in the pediatric population, is increasing at a rate that has some people writing about it and concerned. In addition, some of this came out of this WHO document that we wrote, but even worldwide, there's an increase in testicular cancer. This is female breast cancer that's increasing. These are cases in younger women. Also, body weight index as well as metabolic diseases, including diabetes, both type 1 diabetes, which is really kind of an autoimmune disorder in kids, as well as type 2 diabetes, which when I was growing up, we called it juvenile diabetes for type 1 and adult onset diabetes for type 2. And the pediatric population is really experiencing a large increase in type 2 diabetes. In addition, there are a number of reproductive endocrine issues that are increasing: breast cancer, prostate cancer, etc., as well as immune and autoimmune issues like type 1 diabetes, asthma, heart disease, stroke, and various kind of disorders of the nervous system. I want to talk a little bit about, because this is probably one of the best known syndromes that is really increasing worldwide. And there was a guy named Niels Skakebæk in Copenhagen who really his whole career he has spent documenting what he terms the testicular dysgenesis hypothesis. That idea is that when a male fetus is, I don't remember exactly what stage during development, but is exposed to some factors, and the factors are probably estrogenic factors, that there's this testicular dysgenesis that occurs, and that dysgenesis during fetal development leads to reduced sperm counts in the adults, an increase in testis cancer, an increase in, this is testicular non-descent in babies, as well as hypospadias, which is a birth defect of the penis. So these things are all linked. These symptoms in adulthood and at birth are all linked to this dysgenesis that occurs mid-gestation. Okay, and there's been a lot of work to try to link that to a single chemical, and that's the other issue that I worry about, because we like to think in terms of one cause, one effect. When I look at the studies that we've done in our lab demonstrating that these chemicals act like drugs, and we all know that drugs can interact in ways that are sometimes really surprising. When you've got 100 chemicals in a fetus, what evidence do we have that there's no interaction between those chemicals that are acting like drugs? And there's nothing on that. There's just nothing on that. We're just in the dark. Okay, so let me talk about the thyroid for a minute. This is congenital hypothyroidism. When a baby's born with a dysfunctional thyroid gland, it's important to begin therapy with thyroid hormone shortly after that. And this is just showing a baby that has not been treated with thyroid hormone and one that has. Before this surveillance system was begun in the 1970s, it would take, 3 months, I think was the average, to detect a baby that had low thyroid hormone, that had congenital hypothyroidism. By that time, the IQ that they would achieve, regardless of therapy, would be around 70. So it has a severe impact, and it impacts quickly. So this is actually a tremendous success story. The US, actually Canada, was the first to start a surveillance system. But we can take credit for it. But it was Massachusetts that was actually the first state in the US to start a surveillance system. Okay, another thing that's important here that goes to the issue of the complexity and how difficult it is to link chemical exposures to some effect, is that thyroid hormone produces different effects at different times during development. A friend of mine, Joanne Rovette, at the University of Toronto, kind of put this part, she's the human person, I'm the rat person. So she put this part of this slide together because she works with kids that have thyroid hormone insufficiency at different times during development. So here's a case where a woman is pregnant in the first trimester and it's discovered that she has low thyroid hormone and they begin treatment. Okay, for that population of babies born to those women, what kinds of deficits do you see relative to a normal control population? And the first thing are these kind of visual processing and visual attention. Also color discrimination. So these, from her point of view, this is going to have a direct impact on school performance because not only visual attention, but also processing is affected. And of course, if you look at thyroid hormone insufficiency at different times during development, you see different kinds of modalities that are being affected. Okay, so you can't just link a chemical that interferes with thyroid hormone action with one output, with one endpoint, and especially if that endpoint is body weight. So that makes it even more difficult. And this I'm just telling you something I already did, which is the fetal thyroid gland doesn't begin to work really fully until about week 20. So let me show you some of the issues with the chemical. This is thyroid hormone here. And the way to look at this is kind of a ball and stick model. The way to look at this is that there are these two rings here. There's a ring here and a ring here. These purple things are iodine. This is why everybody needs to have supplemented iodine, because if you don't get enough, thyroid hormone can't be made. And just as a note, 30% of women in this country have iodine intake, dietary iodine intake, that's below the World Health Organization recommendation. And that's a mistake. We can help ourselves, especially if you're a woman of reproductive age, by ensuring that you get enough iodine. Sea salt doesn't do that. And it might be a conspiracy that Morton salt has iodine in it, but it's actually intended to be good for you. Yeah. That's absolutely true. That's absolutely true.
Is there just a simple blood test to see what your iodine level is?
Yeah, it's a urinary test. So they can measure urinary iodine, and they can do that. Now the thing is, it's called the Wolff-Chaikoff effect, that a large amount of iodine will block thyroid function. The place where this is really important is in pediatric surgeries. So remember that there's an antiseptic that they use that has iodine in it, betadine. And if you slather a baby with betadine, you massively overdose them with iodine, and as a result, their thyroid gland shuts down. That's what it takes. I don't think that you would really have to work hard to induce this Wolff-Chaikoff effect with dietary iodine. It's a very broad therapeutic range, I think. So I wouldn't say don't worry about it. It's something to think about. It's definitely out there, and if somebody tells you that iodine can do both things, that's right. But I think it takes an awful lot. Okay, so here are these two rings, and this red thing in between here is oxygen. And the way to think about this is that you've got these two rings, and their molecules are kind of floppy, and they can spin around. They can spin around the axis of this oxygen, but they can also bend because oxygen allows that to bend. Now the thing is, you've got iodine on there. These are big atoms, they're negatively charged. It's like taking two magnets and holding the negative pole together. You know, they repel each other. I haven't done this for a long time, but when I was a kid, I used to really, you know, it's weird. And you can feel that repulsion, and that's what's happening here. Those iodine atoms are repelling each other, and so it forces the molecule, these rings, to be 90 degrees with respect to each other, okay? And if you've got 4 iodines on there, it's straight across. The oxygen, it's not bent around oxygen. And so this is thyroxine or T4. To be biologically active, and that's a little bit of a stretch, but to be hormonally active, T4 has to be converted to T3. So one of these iodines comes off, and as soon as that comes off, it causes the molecule to cock like this, and that's what fits into the receptor. Okay. So here are PCBs. These are polychlorinated biphenyls. They have these 2 rings, just like thyroid hormone. They don't have an oxygen here, but they've got chlorines, and chlorines are big atoms that are negatively charged, and they serve the same function. These things can spin and occupy different shapes. And when they do that, some of these can fit into the thyroid hormone receptor. Now, they don't fit in really well, although there's a guy in Japan who's been studying kind of an off-target. It's essentially these things, instead of binding to the hormone receptor where the hormone does, it binds somewhere else. It seems to stick somewhere else on the molecule, and when it does that, it causes the receptor to pop off DNA at concentrations that are far below what we have in us. So there's a lot of ways these things can work. Here's polybrominated diphenyl ethers. These are best known as flame retardants. They put an oxygen here. So when Congress banned these, what it meant is that if you're a chemical company, you've got all the main ingredients, let's just change it a little bit, okay? And that's what they did, so now it's legal. It bypasses, it was only PCBs that were banned, not polybrominated diphenyl ethers. Bromine is also big and negatively charged. This thing looks a lot like thyroid hormone. This is triclosan here, which is also, triclosan is what you put in these biocidal soaps. It's in Total toothpaste. It's an antibacterial agent. But if you're going to make something that looks like thyroid hormone, it's kind of this, because it's also hydroxylated. And the oxygen group here can also help it fit into the receptor in a way that has kind of surprising effects. This is bisphenol A. You can't really see it here. Bisphenol A, even though we think of it as an estrogen, it doesn't look like an estrogen at all in terms of the molecule. It looks much more like thyroid hormone. And it binds to the thyroid hormone receptor. And we don't know a lot about what that does. Okay, so let me talk about PCBs for a bit, because I think it's a great example. PCBs were banned by Congress, not by regulators. So let's think about what we know about them now. There was actually a lot of uncertainty about their toxicity in the 70s when they were banned. What do we know about them now? Well, first of all, they were used everywhere. These things were great. They were very heat stable. They were used in industrial settings, like in big electrical equipment, like the transformers on telephone poles. You know, these kind of things, they never go away. In the environment, they have a half-life of about 100 years, I think. In people, there's a bunch of different kinds of PCBs, but they'll last from, a relatively short time of some months to a decade. So they bioaccumulate because they stick in us, they stay with us. But they were used also in paints and also clear wood finishes because they had great optical properties. They wouldn't change their color. You know, the varnish that you would put on wood wouldn't get yellowed with sunlight because of that. They're persistent in the environment, they don't go away, and they bioaccumulate. The production was banned, but we all still have them. In fact, the Food and Drug Administration, the food safety side of the Food and Drug Administration has said that these are unavoidable contaminants. They're everywhere. You can't avoid them. So they set maximum tolerance limits. And the maximum tolerance limit for dairy milk is actually higher than the concentration we use in rats, which seems odd because we're measuring effects on brain development. This just shows PCB levels in human milk. This is a big review. These are all different studies, and this is the range of PCB levels that they were measuring. And these are high. This is nanograms per gram of fat, so we're really talking about, you know, micrograms of PCBs in milk. A newborn drinks about 650 mils of milk a day. I think it's something like that. Okay, there are a large number of studies. This is one that I really like because they also did some MRIs to show that in kids, so they're looking at kids that I think were at the time 6 or 7. This is a prospective study. Well, it's at least a historical study. So they've measured the same kids a number of times to determine whether or not the cognitive deficits are persistent. And in this case, what they're looking at is percent of commission errors. So these kids are given a task on the computer, and they're only supposed to push the button if a certain symbol comes up. And they just keep pushing the button all the time. And so the higher the level of PCBs they have in their blood, the more likely they are to push the button inappropriately. And this is linked to a smaller area of the brain called the corpus callosum, and it's a certain part of the brain that we actually know is regulated by thyroid hormone during development. Now, we can't go into those kids and say that thyroid disruption was the cause of this anatomical deficit as well as these behavioral deficits, but there's a lot of animal studies that support that. And in fact, when you look at all of the human studies that have been done worldwide, they all pick up negative associations with measures of cognitive function and blood levels of PCBs. So there's no question that prenatal exposure to PCBs affects cognitive function. And this is affecting performance. These are lives here that are being affected. So, based in part, I forgot when I started. So based in part on much of what I've been talking about, the American College of Obstetricians and Gynecologists, as well as the American Society of Reproductive Medicine, just published a report that is about toxic chemicals. And what they say here is that reducing exposure to toxic environmental chemicals is a critical area of intervention for physicians. So they're worried about this because of all the reproductive effects that are linked to pesticides and a variety of chemicals linked in more than one studies. This group of physicians is making this kind of statement. So the American Chemistry Council and their director of medical something, where is that? The chief medical officer of the American Chemistry Council had a rebuttal. And if you look at the dates here, this rebuttal actually came out before the date of the ACOG. What they say, what this chief medical officer says, I'm going to skip this part. We're concerned that it inappropriately draws conclusions based on biomonitoring data. That is, the CDC's biomonitoring studies. In fact, the CDC says, as they point out here, that just because a chemical is found in you, it doesn't mean it's bad. And that's absolutely true. Just because it's there, it doesn't mean it's bad. Now, we know that some of them are. Out of the hundreds of chemicals that are found in the human population, we've got very good evidence that some, a bunch of them, are bad, but they're still there. What it's also saying is, if you think about the 100 chemicals in cord blood, they also don't know that it's safe. Okay? They don't have to do any safety study on the chemicals before they put it into the environment. They have to tell EPA that they're going to put it in the environment, but they don't have to do any studies unless it's a pesticide. Then they have to produce some science about this. Okay, and I'm going to have to cut this shorter than, well, it's not really short, is it? It's no longer short. This is kind of the series of tests that they use to determine whether something is an endocrine disruptor. This is from the EPA. This took $100 million to validate this over a period of 10 years. So what are they looking at? In most of these, I'm going to skip this part here, they're looking at the weight of the uterus here. That's the main thing. They're looking at the weight of the prostate and seminal vesicles here. Here they're looking at the timing of puberty. What they're really looking at is measures of acute toxicity. They're not looking at measures of hormone action. And so the question is, does organ weight reflect toxicity? And my analogy here is, what if you had this neat car and you brought it to me because the engine didn't start? And so what do? I pull the engine out and weigh it. I mean, how many people think that would be, you're glad you came to me as your mechanic? The other point that I want to make here is that in addition to this as an analogy, I can extend that analogy by saying, what if the engine works fine and you bring it to me because the back wheels don't turn? Well, I still pull the engine out and weigh it because that's what the guidelines say. Every chemical that goes through these assays have the same things done on them. These assays and the endpoints in these assays don't map to human disease in the population today. It doesn't map to diabetes. It doesn't map to obesity, cardiovascular disease, attention deficit, Alzheimer's, autism. Autism has an incidence of 1 in 50. At what point do we stop making excuses about our inability to have complete confidence? Okay, and I'm going to have to... I really like this car picture, though. I'm going to have to stop there. I was going to talk about bisphenol A, but we can talk about that later. I also want to say that one of the things that people talk to me about are specific products. And I'm much more of a kind of hormone guy, a mechanism guy. And so I've partnered with a professor at UMass, Cynthia Barstow, who is in the business school, and she's the one who really knows about all the products. So if you have questions about individual things, she's the person to talk to. Otherwise, I just have to say, good question. So I'll leave it at that. Thanks for your attention. So questions?
Now, in trying to minimize the intake of such chemicals. In recent years, we have seen all the food containers are becoming more and more plastic. Previously, we had glass. At least the glass was stable. Chemicals didn't leach out from glass and all that. But now, even the acid substances like Coca-Cola are in plastic containers.
Yeah.
We really don't know what is leaching out from those plastic containers.
Right.
Well, is there any studies done to say, is there a difference between these chemicals in the food which has been stored in plastic containers versus glass containers, for example?
Right. I can't say I know a lot of those kind of comparisons. I think you're absolutely right. These plastic containers, in fact, I was really hungry the other day and I went to this kind of snack place and I got this kind of granola thing that was in this plastic container and I opened it up and even before I got inside, it smelled like the inside of a garden hose. You know, have you ever smelled that? I think it's PVC. You know, it was horrible. I couldn't eat it. I think for a long time we ignored that kind of stuff, the way chemicals migrate out of these containers. There are a lot of studies done on different kinds of plastics. And actually, so Cynthia has an organization called Protect Our Breast. And I'm one of the science advisors on that. But another one is a guy named John Warner, who is really the father of green chemistry. And his kind of argument is that what we should do is not look at individual chemicals in, you know, that go into the ingredients, because in fact the studies that have been performed like this, you take known chemicals, you make it into plastic. Once it has formed plastic, grind it up and then do the measurements of what chemicals are in there. You create a lot of chemicals when you make plastic, and those chemicals can migrate into the food that it's holding. So in fact, his argument is, let's not look at all these individual chemicals. Let's take the end product. The thing that he likes to say is, take your iPhone and grind it up and extract all the chemicals out of it and see what's in there. Because from his point of view, even if it doesn't migrate out when you're using it, it ultimately is going to wind up in a landfill somewhere at some point in time. And then it's going to start to break down, and we need to think about the whole life cycle.
Many years ago, I was involved in doing some research around reduced sperm counts, and I assume what you're discussing was, and it was all linked to unknowns, but most of it was pesticides and trace and things that were changing in the environment. I assume some of the newer evidence is linked to that same phenomena. What you were just
Right. It's been done in many parts of the world, and Shauna Swan, who's now at Mount Sinai in New York, did a study in 4 different regions of the U.S. And I think the worst was Missouri, where she was at the time. Maybe that's why she left. But these agricultural areas that have a lot of pesticides that they're using, sperm counts were lower there. There was a big debate about whether or not there's a secular trend over time. And the way Niels had done this, his first paper was in 1992, is they had slides that they had archived for years. And so he was looking at a bunch of old slides and then looking at new slides of sperm counts, and basically came to the conclusion that there's a secular trend. There was a lot of debate about that, but I think that all those data have held up.
Hi, so I have a 4-year-old and a 1-year-old, and I'm going to go home and give my 1-year-old milk. Mm-hmm. What do you suggest I do? Or what resources, I know about the environmental working group, but what other resources would you suggest for parents of young children? Thanks.
So Cynthia can probably answer that better than me, but I think when you have to eat. So I mean, from a real point of view, first of all, if you can buy organic, you pretty much guarantee that you're going to reduce your exposure to pesticides. There may be other things in there. You know, you can buy milk in glass containers. I think that if you're going to heat up the milk, you wouldn't want to do it in plastic containers, that kind of stuff. So think about the vessel that you're using, you know, the cup or whatever it is. And, you know, try to buy products that, I hate to say, that are BPA free, because that doesn't always mean what you think it might mean. But we can only do what we can do. I think the other thing that's important is to I hate to say this now, but let your Congress people know, let your legislators know that you're concerned about this issue, even more than they are.
What is your take on non-stick
Yeah.
material that
Polyfluorinated.
non-stick cooking vessels?
Yeah. The bad part about the chemicals that make Teflon is that they don't go away ever. Nobody has ever measured environmental degradation of perfluorinated chemicals. So we can measure the rate of degradation of PCBs in 100 years or whatever. These perfluorinated chemicals are not going to go away. At the same time, they're lipophilic and they biomagnify. They're not going to go away in us either. In addition to the kind of, you know, you think of it being immobilized on a pan. Of course, that pan is going to have some lifetime, and, you know, if you're using a metal spatula, etc. But they also put the same perfluorinated chemicals on paper so that they put your hamburger in that because they don't want the grease to leak through, you know, this paper. These perfluorinated chemicals are being used in a lot of places. And it's crazy in my mind to put something in the environment that's just never going to go away. I can think about the scientific apparatus today compared to when I was an undergrad. It's massively different. It seems naive to think that what we know today is all we're ever going to know. You know, in another 20 or 30 years, we're going to have all new technologies and abilities to be able to determine the toxicity of chemicals, and then it's too late because they just don't go away.
What about DEET used for bug sprays or sunscreens, lotions that we put on our faces and bodies every day?
Yeah. So I don't know that much about DEET. Personal care products, not just lotions, but all personal care products can have a lot of chemicals in them that interfere with hormone action. Phthalates are a big kind of a big category, and whenever you have lotions that have a lot of fragrance associated with it, oftentimes phthalates is the carrier for that fragrance. And of course, a lotion is really a delivery mechanism. You've essentially got this material that you're rubbing onto your skin, and it goes into your skin, and whatever's in that lotion is going to go into your bloodstream, and people have measured that kind of stuff. So I think the important thing to do is to buy products that, I think scientifically we can't ever say it's safe, but we can certainly say it's a lot safer. And this is really what Cynthia does. Cynthia and her group, and she's got these tip cards that have print on it that I can't read. But that's for really good advice about that kind of stuff. And Cynthia, the really fun part about this is that Cynthia is running this program with students. So students in the business school are really getting involved in these kind of issues. And one of her students that graduated last year, is now working for some
JP Morgan.
JP Morgan, which means something to some people. I'm a Ford man myself.
Just to follow up on Mary's question, in some of the research that that they're doing on levels of body burdens of chemicals, are you seeing any significant differences between men and women? You know, again, thinking that, you know, women wear makeup, we wear nail
Right.
polish, we dye our hair, and we're most often the ones who are doing cleaning, you know, with chemicals in the household. Thank you.
That's a good question. And I think when those kind of studies are done, they do see differences. You know, people that, you can almost call it an occupational study because you're really, you know, different people have kind of different roles that brings them in contact with these kind of things more often. Now, Shauna Swan did a study on, this kind of sounds funny, but for an endocrinologist, it's not. She did a study a while ago linking phthalates. So phthalates are in these personal care products, but they're also in a lot of things. The deli wrap that you put cheese in has a lot of phthalates in it. It makes plastics flexible. She was linking blood levels of phthalates in women at childbirth with the anogenital distance of boy babies. Now, the reason she looked at that is that's an index of androgen action, and phthalates are anti-androgenic. And what she found was a very significant correlation between the mother's phthalate concentration and the baby's anogenital distance, which for an endocrinologist, for me, I looked at those data and said, clearly, phthalates were affecting androgen action. Well, right away, the industry came out and said, who cares? Who cares about anogenital distance? It's not an adverse effect. I mean, you know, it made the news. But from my point of view, testosterone and other androgens are hormones that are acting in many places. And this is an index that she could identify without, you know, getting too messy. So she did what she could do, and she confirmed, in my mind, a real possibility that endocrine disruption is occurring because of phthalates. That's kind of a story, but she tried to link that to their personal care products. No correlation. So these chemicals come from, you know, a lot of places. What's in your, you know, it's like the old Saturday Night Live, it's a floor wax and a hairspray, you know, that kind of stuff. They use it in many different kinds of products.
You hear a lot of talk about the importance of, at least if you're reading information from naturopathic physicians and those sort of folk, about how important it is to assist the body in the detoxification process. Is there any real reliable data or studies out there that show that any of that stuff actually helps, or really that we actually really can get rid of, or do we even want to? Is it better to just kind of let
Right. It's a good question. One thing about it is that lipophilic compounds will be sequestered in fat. If you lose a lot of weight, you're going to go through a period where you increase the blood level of those chemicals, and then it'll leave. A bunch of studies on PCBs in women that have had multiple children and breastfed. PCB levels in them decreases with the number of children they had and the duration of breastfeeding. So you can get rid of chemicals. I'm not sure that's the best way to think about it. There was a study that was done, though, and this is kind of this. You know, it gets really complicated. So without looking at the specific chemical or method, it's hard for me to answer globally, but there was a study that was done where they took a bunch of people, had them lose a significant amount of weight over a short period of time, and they measured PCB levels and thyroid hormone levels. Okay, well, PCB levels went up and thyroid hormone levels went down. And their conclusion was PCBs causing a reduction in thyroid hormone. If I give animals PCBs, thyroid hormone levels go down every time. So they sent it to me to review it, but my argument was, if you go on a diet, thyroid hormone levels go down. I don't think we can discriminate between these two things here. Does PCBs go up and cause it, or if you stop eating, thyroid hormone levels are going to go down? So it gets really difficult. That doesn't, it more than answers your question.
You mentioned something about avoiding BPA-free, using BPA-free products whenever possible. Can you mention kind of what manufacturers might have done to replace the BPA and what is known about the chemicals that they've used in place of it?
So bisphenol A is in the news a lot. Everybody's heard about BPA and so here's what I know. For example, they put BPA on cash register, these thermal receipts that you get for, your credit card receipt, that kind of stuff. There's a lot of bisphenol A on some of those. On other ones, and you may be better at this, on others they put other kinds of chemicals, and some of those chemicals are modifications of, instead of BPA, it's BP sulfate. And what it seems to be the same. It has the same biological action as BPA. And in fact, there's a group of law professors that have gotten together to sue the FDA, essentially their point is going to be to require FDA for a company to prove that a product that they're selling as BPA free is actually free of the activity that bisphenol A does as an estrogen. And so what they're trying to get the FDA to think about is when you go to buy a product that says bisphenol A free, you think it's free of the activity, not just the molecule. We don't care about the molecule. It's the activity. And if they just replace it for something that is similar, and that's kind of what is being done. Laura Vandenberg is an assistant professor at UMass and knows a lot more about this than I do. Is that kind of close?
Yeah, when the story of BPS came out, that there's BPS and thermal receipts instead, I had a reporter call me and he said, are you saying this thing is called bisphenol something else and we're supposed to be convinced that it's different? And I said, it's interesting because no one else thought that at the time, that these are two molecules that are essentially very similar. So a lot of products that are labeled BPA free are no better. And in fact, BPS, we know a lot less about. So we've replaced something BPA that we know a ton about and we're concerned about it with something else that does exactly the same thing as BPA, but we know less about it.
It seems to me some of the studies coming out of Europe are much more progressive and advanced, and when they find a problem, they actually do something about it. Do you pay a lot of attention to studies that come out of Europe more than what comes out of this country?
Well, yeah, you're absolutely right about that. Europe is much more progressive in terms of their regulation. There's so many things in this country that are not regulated and they're banned in Europe. Artificial food coloring is a good one. I can remember hearing somebody say, if we get rid of artificial food coloring, all the food is going to be gray. It just won't have any color. And go to Europe sometime. You don't see that everything is gray. Atrazine is another one. Atrazine is a pesticide that's used extensively here. and is linked to many health problems. In Europe, it's banned. You know, why is the culture that different? Is it politics? I mean, I've often thought that what it is you've got these countries that have a recent history. So you're not going to get a German chemical company to go to France and pay them off. No Frenchman would do that. Because of that, we don't have that here where, you know, somebody from Indiana comes from Massachusetts and it's a big problem. You've got a central government with a beltway that circles around it and it's filled with lobbyists. And I got a feeling that a huge problem in the US that doesn't occur there as much, it occurs some, is that lobbying is much more centralized than it is in Europe. You've got these countries and their regulators are spread out all over Europe, 27 different member nations. And I've been on some of the committees in Europe debating the issues of endocrine disruptors because it's a big, they have what they call REACH legislation. Starting January 1, pesticides that are considered to be endocrine disruptors will be banned. And there's a huge fight right now over what is an endocrine disruptor, and this whole thing seems to be stupid. There was, it's a great story actually. A bunch of toxicology journal editors wrote an open letter to the European Commission saying, you guys are making a huge mistake. You're basing all this stuff on emotion and no science, and it's just crazy. And they got much more than what they bargained for because several groups of international people, you know, across, even in Asia, wrote in response to that. In fact, the last set of responses came from, I think, 48 editors of endocrine journals. These are editors, you know, in New Zealand and London and many states in the US who even wrote their own comments in their own journals, all basically saying that they're way off track, that the evidence is there. And these are people that don't even work on endocrine disruptors, many of them. You just look at the data as an endocrinologist and you know what's happening. So you're right, they are more progressive. I think politics and money has a big part.
This also brings to mind the almost epidemic information that's coming out of the fact that young women, a lot of them are infertile for many different reasons, and also the Japanese have found this to be happening in their society. The French have found young men not able to bear children, possibly due to the use of fertilizers and things. So what happens when the males can't produce and the females can't produce? Our world is heading.
Well, the issue of infertility and reproductive deficits is probably one of the best understood secular trends. In fact, I've known Niels Skakebek, who began this kind of work in Copenhagen in the kind of 80s, and one of his proteges got up and gave a talk at the Canadian Diabetes Association, and she was saying that it has gotten so bad in Denmark that high school girls make a joke that, you know, if you want to have unprotected sex, make sure it's a good Danish boy. So that's how significant it is. Now, it's a joke, and it was a woman who said it, so I feel a little bit better, but you're right. This is becoming clear to everyone that reproductive problems are huge, and it's not getting better. And interestingly enough, what Niels, one of the great studies that he did was to demonstrate that that sperm counts and testicular cancer is associated with the year of birth, not with the year that they were taking these studies. Now, what that means is that whatever happened in utero, but it doesn't manifest itself until they're adults. That makes it very difficult. I know some people could say that men just blame women for everything.
Quick question. Our department orders water from, like, I think it's like Poland Springs. I don't know, one of these companies, but it comes in those big I think they're polycarbonate containers. Are they something we should be concerned about? Is there leaching from the polycarbonate?
I kind of think of it a couple ways. One is we do the same thing in my lab. We have Poland Springs that comes in and they bring the carboys and they changed them. So I don't know what they changed them to, but they used to be straight polycarbonate. Now it's a little bit different. I would kind of argue, it's hard to argue, you know, water's good and you kind of have to drink. It's probably better than tap water, which I worry about more because of what's in the line. But, you know, filtered water isn't bad either. I often think about this, that here we are in a society where it's okay for the water not to really be potable. Otherwise, Brita wouldn't be so successful. And yet we've allowed this to kind of happen. It creeped up on us. Not fast either.
I use hoses for a lot of stuff, and you were talking about how, like, hoses have the bad stuff in them. And so, like, I use them to, like, water my horse and stuff like that, and I water my vegetable garden with it. Could the chemicals get into my vegetable garden, into the vegetables, and then I eat them? Like,
that's a good question. So it really depends. So some chemicals will, and some won't. Boy, that's a great answer. You know, it's a good question. There are hoses that you can get that aren't these PVC things, and they're good for a number of reasons. For one thing, they're more flexible. They don't get cold and kind of snap, all that kind of stuff. So the cheap plastic ones are the ones that really smell bad. The same with the shower curtain. You know, these PVC plastic, you open it up and it really has a horrible smell. You know, plants, the only thing I know about plants is perchlorate. So plants will pick up perchlorate. It's a salt. It inhibits iodine uptake everywhere. But you're not going to have perchlorate in the hose. I keep trying to get out of this slide, and it keeps turning it on.
I think unless anybody's got some really crazy questions and they want to ask, I'm going to kind of close it up so that our sick man can get home. Do you want to just do it right after, maybe? Just so.
Everyone would benefit. I'm just curious as to how we go about getting ourselves tested. Oh, that's not something.
How do we get ourselves tested? Is what she said.
Well, it's a good example. So, as kind of an example, I've got a study. It's a human study in San Francisco, and all we're doing is measuring PCBs and PBDEs, and it's costing us about $900 a sample. So if you try to get yourself screened, it's a second mortgage. You know, it's enormously expensive. So two things that I can say real quick. One is that there's an estimated 140,000 chemicals licensed worldwide. You know, in the United States, there's about 80,000. That's kind of the number that's bandied around. 3,000 are produced at levels of 1 million pounds per year or greater. Out of those 3,000, maybe 200 have been evaluated for safety. In addition, one of the slides I didn't get to, the Pew Charitable Trust just finished a review of the FDA food safety. First time in their history that they've ever been reviewed by an outside entity. What they found is that over 60% of the chemicals that they approved as food additives have no toxicity data. So what do you do with that? You know, we can do the best that we can do. I think there are certain things that we can say in this tip card that Cynthia has as a really good resource to do what we can do. But we also have to change the system.